On this episode, Scott and I welcome Richard Hughes, Senior Principal Software Engineer at Red Hat, to discuss introducing fwupd and the Linux vendor firmware service. Stay tuned for this edition of Eclipsium's Below the Surface. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Welcome to Below the Surface, the firmware and supply chain podcast. This is episode number 7 for today is April 5th, 2023. Welcome. My co-host, Mr. Scott Shefferman, is here with us today. Scott, welcome.
Hey, thanks for having me again. This is always fun. Paul, we have an amazing guest today. I'm so excited.
I am also excited. Just a quick kind of housekeeping note. I did give a webcast this week as part of, it was for SE Magazine, actually for CRA, wearing my Eclipsium hat. And we talked about the top 5 things that you can do to protect your supply chain. Right now, if you check my Twitter account, I retweeted it. It's probably the easiest way. My Twitter handle is Security Weekly. If you go there, you can find that. My co-host was Bill Brenner, and we had a great discussion about firmware security and protecting the supply chain. Speaking of firmware security and protecting the supply chain, I want to introduce, a couple things. The Linux vendor firmware service, which we'll dig into, which is a service you can, the links are in the show notes. You can go there and check out the project and some of the aspects about it. You can also get the software fwupd, which is software that runs primarily on Linux-based systems that allow you to enumerate the hardware and firmware that is on your system and in certain circumstances apply updates to that, as well as evaluate the security of your hardware and firmware. Our guest today is Richard Hughes. Richard has over 20 years of experience developing open source software, 15 of which are at Red Hat. He is the maintainer of LvFS, fwupd, libxmlb, odrs, the original creator of GNOME software. Do you say GNOME or GNOME?
I don't care.
AppStream, glib, and a host of other projects that he contributes to on a regular basis. Richard graduated in 2007 from the University of Surrey with a master's in electronics engineering. He now works as a senior principal software engineer for Red Hat, focusing on LvFS and fwupd. Richard, welcome to Below the Surface.
Thank you. Thank you for having me.
It is so wonderful to have you here, Richard. And I don't know at what point I discovered LvFS and fwupd, but I instantly fell in love. I am a Linux desktop user of probably 7 or 8 years, like 100%, 7 or 8 years. My computing devices, PCs and laptops have run Linux. It's in the unwritten contract that I'm obligated to tell you and everyone else that I use Linux on the desktop. And since then, and it probably was when I started at Eclipsium, and I wanted to update Intel ME. I'm like, well, how do I do that? I'm like, how do I update all of these firmware and hardware components that live inside my computers? And that's when I found your project. So, Richard, how did you get the initial idea and inspiration to create both LvFS and fwupd?
That's a great question. So I guess it's to scratch an itch. So a long time ago, I made a open hardware display colorimeter, which basically measured color on a screen. And as part of that, it had firmware, and I wrote a firmware updater and a little web service that ran and just supplied firmware for people. And I thought, this is rubbish. Like, why should everyone who builds a device have to have a different protocol, have to have a different web service and signing and all the stuff that everyone gets wrong? Mm-hmm. I thought, this is way too generic. And I'd already done something similar with PackageKit, which I designed years ago, where you basically had a central, common daemon process, and then other stuff that just kind of plugged in to add support for other things. So I thought, well, maybe I could make this generic. And about the same time, Peter Jones was developing this thing called Firmware Update, which was a way of updating capsules on Linux. And we said, well, look, if we could sort of squash these projects together, so we have the USB updater for this color hug device and the Eufy thing, then maybe we can make a project that does both. And then Dell very quickly afterwards said, look, we need something for our XPS and IoT hardware. We wanted to do something like what you've done, but you've done it already. Can we just basically add our stuff to your project? And I said, yeah. And then it basically snowballed. Now, actually applying the update and enumerating the hardware is, okay, it's interesting, it's useful, but the value was providing both the metadata, which says there is an update available for this hardware, and also the files themselves. Like so many vendors have, I don't know, like ftp.dell.com or something, which may or may not exist in 5 years' time. And they don't have signing or the signing keys like out of date, or they'd have checksums or the most basic of things. So I thought, well, if I just knock together a quick and like nasty Flask application, which lets vendors upload firmware, that provides me the metadata so I can tell people that their hardware is out of date, and also the files themselves to do the deployment. Fast forward 5 years, we now have like 140 vendors using this service. We've supplied 84 million downloads, possibly as much as an order of magnitude more than that, because the whole LvFS, because it's all open source and it's all like open access, anyone can mirror it. Like, so if you're someone like a 3-digit US agency or Pixar or DreamWorks or someone, you just mirror the entire archive and you deploy it internally without internet access. So it could be that this thing's been used like 1 billion times.
So, Richard, it sounds like you're solving 3 problems. One is knowing what hardware components are inside of your computer or server.
Yeah, I call that the enumeration stage.
Enumeration.
So, for instance, a good example is my ThinkPad. Like my ThinkPad has, I think it's 14 individual components that are updatable inside the ThinkPad, and then the dock that attaches it has another 12. And so you have 2 like composite devices, the dock and the laptop together, and you have dozens and dozens of things that you didn't know had firmware. Like for instance, the ThinkPad I have in front of me, the little red dot that lets you do the think whatever it's called, the one in the middle, that has firmware. That has independent firmware from the keyboard.
Yeah.
So even the stuff that you don't necessarily think would have firmware
has firmware. And then the second thing is knowing if the component has an update or not, and where to find it. So maybe there's like number 2 has like 2 sub problems, right? Like, is there an update? So, and then like, where do I find it? Those have been in technology for as long as Scott and I, anyhow, because you might be a little younger than we're old, man. Like,
pretty old.
Figuring out like the firmware has been a never-ending battle.
So the thing is, if you go back 5 years, like we had like 4 problems. So people didn't know what hardware they were actually using. So like a good example is like, are they running a SATA disk or an NVMe disk? If they're using a NVMe disk, are they using the firmware that the OEM provided, like Dell, or are they using like the SanDisk firmware, the generic one? No one knows, right? Next thing is, where do you actually get the firmware from? If you got your PC from Dell, do you go to support.dell.com to update your NVMe drive, or do you go to like Samsung or Micron or whoever the actual like, the component supplier was? That's not clear. If you manage to do those 2 steps, you get to the 3rd step, where you get an updater, which might be an exe file that runs on Windows 7, which is used because it won't work on 64-bit PCs or whatever. I have an LG monitor which only can be updated in Windows 7. And then if you manage to get that download, it might not be signed. You might have to turn off secure boot to run an ISO or something. And actually, when you do apply the update, there's no way of telling the vendor whether it succeeded or failed. And so you have zero confidence in the whole process actually happening. And I thought those 4 problems, each one of those needed solving. And that's kind of what we've done over the last 5 years with fwupd and LvFS.
But it still doesn't update. Does it update Intel CSME?
Yeah. So the way we do that is through Update Capsule. So, the biggest like success and flaw of LvFS is that it requires the vendor, like the OEM, Lenovo, HP, Dell, whoever, to upload the firmware. And so on your I don't know, Linux laptop, you have a ESRT table which says this is all the components in the device, this is their version. And then all we have to do is match the GUID in the SRT with the GUID that the vendor uploads to the LvFS. And then if it matches and the version's bigger, we offer to download the cab archive and deploy it on the system.
I got you.
So yeah, long answer to the short question is yes, we can do the CSME.
But I think what some people may often don't realize is that that update has to come from the last leg in the supply chain, so to speak, as the OEM, because they've customized hardware and firmware along the way to make up what ends up being your PC server or laptop.
Yeah, it's bad because the CSME will be signed by the platform key for the hardware itself.
Right.
It's not like you can go to Intel and say, "Hey, can I have the latest version of the CSME?" because the vendor hasn't provided me one. It has to come from the vendor, which is a disaster because 80% of people are running CSME versions that are critically vulnerable. And as soon as the laptop's no longer supported by the OEM, which for something like a laptop, for a gaming laptop or something, might be, there are no updates.
Correct.
So as soon as you bought the laptop, it's insecure. It's terrible. So there's some solutions to this. Like I think Intel are starting to claw back the process. So things like microcode, where they'd relied on the OEM to pick up microcode updates.
Yeah.
And then something like Spectre Meltdown happened, and we found that actually the OEMs were really bad at that. For the latest version, Intel are actually going to be shipping the microcode directly via LvFS to end users. So that kind of solves one of the components.
And they can do that because the keys and all that stuff are on the actual chip, on the CPU, right? That validates
microcode gets tricky. So actually the way that it's implemented for, I think it's Alder Lake Plus, is that there's a separate ESRT entry, and you deploy onto that, which gets copied somehow into your SPI flash, which gets used by early boot. But yeah, Intel signs the microcode.
Once it puts it on the SPI flash, it has to be signed, and there's keys on the CPU that validate the update.
Yeah. So yeah, so it's really early in the boot up.
Scott. Oh, Scott, you're on mute.
Thank you. This segment is often about the threat landscape as well, and I know you have insights into there, and there's a lot of applicability for what you've built in the context of just preventing threats. I had a curiosity question: is whether or not you also have like not a blacklisting, but known malicious firmware binaries that you also look for in the context of what you've built.
So we have way better than that. So it's awesome. It gets complicated quickly. So one of the conditions the vendor sends me the firmware, or uploads the firmware, and one of the conditions of them uploading to the LvFS is we're allowed to do anything we want to that image. And so if you upload a random like Lenovo X1 Carbon image as Lenovo, we'll take that image, we'll look at the file volumes inside the update, we'll take the individual EFI binaries and all the different microcodes and everything, index them in a database, and then actually do static analysis on each of the EFI binaries. So when then we can run it against things like Firmware Hunt, which is our Binali product, which basically allows us to look for specific signatures. So as long as we have those signatures of things that we're looking for, we can do some quite cool stuff. So one is if a basic example is microcode. So what can very often happen in like a company like Lenovo, you might have the security response team, which uploads a new firmware, which adds a new microcode for something like Spectre Meltdown. And then you have like the normal firmware team who then 3 months later upload the next version of the firmware, which actually downgrades the firmware from what the security team did. So there's two different teams uploading the same product. And we can now detect that and say, hey, you've downgraded the microcode. Is that really what you want to do? And we've caught that like 4 or 5 times now.
That's awesome.
That's awesome, but we can do more awesome. So some of the other rules we look for is things like where vendors have fixed like SMM RTT issues or something, where we know there are like key bits. When we decompile the EFI binaries, we can look for these signatures and know very clearly if the vendor has reverted that change and actually gone back to having an insecure set of DXCs or PIE module, whatever. And what's even more cool, when we have a vulnerability that comes out and we get notified it through the event system from CERT, we can add those rules, find out which vendors are affected, which models are affected. Because normally, if the update's opened up against Lenovo, it also affects Dell, HP, and all the others. So we get all of the PCERT teams all together. And then when we've got a rule which can detect the vulnerability that's being fixed, we can prevent any vendor accidentally breaking embargo. So it can be, for instance, the vendor will push the update to stable, say, 2 or 3 days before the embargo date. Now, if I can do static analysis on these EFI,
so can the attackers.
With a black hat, sure as hell can as well. So now we actually say, look, if by pushing this update to stable now, you'd be breaking the embargo just from having these static analysis rules.
No, that's huge. That's absolutely huge. I mean, that's almost half the battle in many respects in terms of just addressing the supply chain threats and vulnerabilities angle. 100%. What's
frightening is how many vendors that don't care. So, for instance, like microcode, like I've got this nice graph on the LvFS website, which basically shows the latest version of microcode available for all of the models on LvFS. And I'd say probably more than half of them haven't got a microcode that was released in the last 3 years. And that's the newest version available. So if you can imagine, if you can extrapolate that through to CSME and everything else, it's pretty bad.
Richard, now I just want to hit on that point for a moment. I always theorized that the end user or the enterprise IT team were the ones making the conscious decision to say, I'm not going to apply these CPU microcode updates because it may have a negative impact on performance. I think is the number one reason. They likely understand the risks, right, to a certain degree, and go, yeah, but performance outweighs that. But what you're making it sound like is, and I'm not sure where it falls, but the other factor is they may not be getting that update, or it could be downgraded in the process.
So a few questions to unpack there. So one is that if you're applying microcode updates when the kernel starts, you're about a minute too slow, because our microcode needs to be done like at early boot rather than kind of trying to patch it up like after time. Because if doing it after, there is like a theoretical attack window and it goes wrong in multiple different ways. And so the only real way you can do microcode properly is putting it actually in the like early stage firmware. And then the other bit of the question I can't remember.
What leads to a high percentage of people not applying microcode updates? Is it the OEM or Intel not releasing them, or is it their reluctance to patch because of negative performance impact? What's the split? What's the split? Because you have some data. I think you have some data on that, right? Basically.
Yeah. So most people, when offered a security update, tend to take it. Like it's very, very small the number of people that get shown the update which don't actually deploy the update. Sometimes what happens is you have like, if you have someone like Google, they might do like 50% of their fleet 1 week, like 45% the next week, and then 5% like a month later. So you kind of get this weird kind of the data blobs. So that's a bit weird. With firmware, the hard bit is getting the OEMs to care. Intel will issue microcode for everything, and then the OEMs might have literally one person building all the firmware in individual VMs. So for something like I don't know, like a good example is like a Lenovo model. You might get the flagship models updated and released the day of the embargo, and then the models that are coming up to their 3-year end of life might not be updated for like 60 days after, because there's literally one person manually building firmware, manually uploading stuff. It's all horrendously manual.
That's really interesting.
In the data, we've got data of when models are updated for what vulnerabilities, and you can actually see when people go on like Golden Week and go on annual holiday.
What you know, when you work with folks in the field that are using this, I'm curious, like if you had to guess from, let's say, the Fortune 50 or the Fortune 500, what percentage of those organizations are actively building the LvFS feature, if you will, into their production, into like their whole tech refresh cycle. So, acquisition, you baseline, maybe when you sunset the device, they take another baseline and look for deltas to find badness, for example, or to get an understanding of like device drift and the firmware drift over the course of the lifetime of the device being operational. Do you have any insights in there in terms of like adoption for like the Fortune 50 or Fortune 500?
So it's tricky. So a lot of the companies, a lot of the very big vendors and the agencies of, I don't know, like UK government, French government, etc., are very secretive. And I don't actually get the data because it's all mirrored and then distributed internally on like an NFS share type thing. So I don't get any data of actually when things get applied, which is probably a good thing as well. Yeah, so there's lots of so LvFS is basically supplying the metadata and the firmware itself. fwupd is not really applying policy. It's really just the mechanism for install this blob on that device. And then usually there's some sort of per vendor or per company, like policy agent written on top. So I don't know, for instance, Google might have something written in Go, which just has this policy agent which tells you what to do. Chrome OS has some other thing. In GNOME, we have this GNOME software, which is sort of like checking if the user's idle and stuff. So actually, we don't get an awful lot of data about like when and why things were applied. All we get is there was a download for this device.
Okay. Yeah, for one model or whatever. Yeah. Mm-hmm. Okay.
It's actually an interesting thing. I got pulled up by a security service, and they said, "Look, we want to know all the data about what devices people have." And I was like, "I don't have that data because it's totally decentralized. It's like a privacy-centric kind of design where everyone downloads a shared metadata, like a common metadata file, and then you only request stuff as and when you need the update. And unlike Windows Update, we have like a bespoke query, so that Microsoft knows exactly what hardware you're running at all times."
Oh, I see. So each user, Richard, downloads the entire metadata to their system, and the analysis happens locally on their system.
Yeah, which is, for me, it's great because I can spend like $50 a month on a geo-replicated CDN, which provides I don't know, 100K metadata file, which means I don't have to have like banks and banks of servers all processing these bespoke requests with all these business logic rules.
Go ahead, Scott. Did you have something? I was going to share.
Yeah, just really quick. So kind of centering on the threat landscape, right? So do you have either just casual kind of observations with people like, let's say on forums, or that send you an email saying, I've had this security type of problem? What I'm trying to ask is for our listeners, many of which may not realize kind of the gravity of the type of impacts and the type of likelihood that can occur at this level. What kind of, I guess, telemetry or observations have you had, based just on interacting with people that you work with on the project?
So we can do better than that. We can do better than forums. So we have this tool called HSI. So HSI is the host security index, essentially. So all the machines that have this test run get a score from 0 to 3. 3 being like super secure, good for a foreign journalist somewhere. 0 being totally insecure, could sit next to you at a cafe and hack you. So it's like a sliding scale, and that's supported in all the different architectures. So if you run something like fwmgr security, it'll do all these security scans and say, hey, look, your BIOS is currently writable by root. That's really bad. Or your CSME is critically vulnerable, or your swap is unencrypted. And it'll run through all of these tests. Some tests are Arch specific. And then right at the end, it'll say, do you want to upload these results to the LvFS? And so now we have 50,000 reports on the LvFS of what actually hardware exists in the field. And that's how we know that 80% of CSME versions are critically insecure, and in the wild microcode versions and that kind of thing. It also means that when you're actually buying a laptop, you can go to the LvFS and say, let's compare a X1 Carbon Gen 5 against a Dell XPS, and sort of compare them one against the other. Which one is more secure? You can't tell exactly because you can obviously change things in like the BIOS settings and things, but you can see, for instance, that the X1 Carbon doesn't enable, KDMA or something, and the Lenovo does. Also interesting, I could talk about this stuff for hours. Also interesting is the fwmgr security also allows you to fix stuff now. So over WMI, you can actually change firmware settings. And so if you're on fwmgr security, it'll run through and say, look, this is bad. Like your Thunderbolt is insecure and your CSME is bad. Do you want to update your CSME now? Do you want to change the firmware settings so that your sleep is secure? Do you want to turn on encrypted swap? All that kind of stuff. So it actually asks the user to fix stuff, which is super useful.
Yeah, wonderful. Paul, back to you.
Yeah, no, that's really great. What are some of the most common, Richard, security vulnerabilities that you're finding in your data for HSI?
So do you mean from the firmware that's been uploaded or from the devices in the field?
From the devices in the field.
So devices in the field, it's usually insecure versions of stuff. And it's usually nothing that the user can fix. So like, for instance, Dell, Lenovo, HP, etc., have very good coverage. Anything in like server or IoT or the gaming motherboards are really guilty of this. Most of the stuff is like both insecure and out of date. So I actually had some good dialogue with Gigabyte recently. Gigabyte sort of famously don't really have a PSET team. And I managed to get through to the actual BIOS engineers themselves to say, hey, look, your ME is still in manufacturing mode. Like, we could very easily attack lots of MSI machine, lots of Gigabyte machine. Can we fix that? And once I'd understood, like, literally explained to them how to fix it, they're like, okay, sure, we'll fix this for the next product releases.
That's amazing, because I think the one system I have that has manufacturing mode might even be a Gigabyte.
Yeah, it's terrible. So it's totally insecure. Like, you could just essentially brick the machine using root.
And the only folks that can fix that are the folks you talk to, BIOS engineers at the.
And it's frustrating when you've got like an XPS 13 or something. There's enough profit in that model for Dell to have that team and have support for 3 to 5 years, etc. But when you have like a gaming motherboard where you have like $5 of profit per unit, you don't have that kind of margin where you can have like firmware updates for 5 years or something. And it's just hugely frustrating when you're just basically throwing perfectly good hardware away because it's critically insecure.
You know, but that's really interesting. I never thought about it like that. When you're marketing a gaming component like a motherboard, you're heavily competing on price, because everyone that's building a computer has gone to a PC part picker. What's compatible? Sort by price. I want the cheapest one. Guilty, right?
And also speed as well.
Yeah.
You know, like if you're optimizing for speed and price, security comes very low on the list.
So I got to ask.
Sorry, I was just going to say, but also on that point, sorry, Scott, is before I lose it, is you're also not keeping that hardware very long. So it's not necessarily a good financial investment for companies like Gigabyte to go, I'm going to support that for 5 or 10 years. Because your typical gamer is going to go, I'm going to rebuild, I'm rebuilding with the latest hardware as often as my budget allows.
Yeah, it's a shame because most people have a gaming PC that they don't just do gaming on. They might do internet banking, or if there's a laptop, take it to a cafe.
Yeah. So gaming, I got it. Former gamer. That's actually how I got into cybersecurity in the 90s. But what insights might you have or might not have related to like hyperscaler environments and those types of devices and the firmware they ship with?
That's super interesting. So before this year, we had no server vendors using LvFS, and now we have 3. But it's very difficult to get them to release firmware publicly. They will have they're all testing stuff in secret. So like I include, I can't name names, but big hyperscalers that you know of. What's more interesting is like the Facebooks and Googles of the world, where they're putting things like Core Boot on their servers. And actually, one of the things that was worked on by Googler for a while was actually installing fwupd onto the BMC. So rather than updating the BMC using fwupd, running fwupd on the BMC itself, which is either like beautiful and genius or insane. I haven't worked out which, but it works. And so you can actually update anything that's attached to the BMC using fwupd, even though it's
but if you had access to the BMC as an attacker, which is very often the case, you could do fun things with LvFS there.
Yeah, but I don't know. You could go either way on this. I think you can make an argument either way. But having fwupd on the BMC means that from outside the BMC, so on the normal hardware that the operating system's running on, you don't have to provide a facility to update. Because if you did that, and an attacker were to find a vulnerability in that, they could then jump on the system and start, gaining higher privileges on the BMC, right? So I think there's lines in the sand, not even lines in the sand, but there's prevention mechanisms there so that doesn't happen, correct?
So in all honesty, looking at the BMC software that I have, it's almost universally terrible.
Yes,
so
it is.
OpenBMC is the only kind of like properly designed system. Everything else is disastrous. Even so, I've been working with the Culvert guy at IBM, who designed like security testing for the A-Speed chip used in most BMCs.
Yep.
And even on the most expensive, like $10,000 servers, all the protection registers are set incorrectly.
Oh, interesting.
Yeah, permissions, like there's Lua on there, there's a web UI.
It's actually worse than that. There's things like VGA arbiters and things where you can just transfer data to and from the BMC from the host OS. So for a long time, you are of the opinion that if you're running on a server and you wipe the host OS using the BMC, then the machine is clean. But actually, if you have like shared access using an arbiter between the BMC and the host machine, it could be that the machine is compromised. And so when you install the new OS, you can use the access you have to the BMC to infect the OS that's just been deployed. It's terrible.
Yeah, that echoes our Cloudborne research in 2018. And there are a lot of data centers that weren't doing anything to the BMC, maybe resetting the password. But if you go from the host down to the BMC and then you get another third-party tenant that gets on that same steal, now you can attack from the BMC right up to the same the new guest. And
what is
do all
a lot of vendors I talked to recently, they're not using the BMC like you would traditionally. Like traditionally, BMC, you'd have like a BMC specific network with its own Ethernet cord and a host OS, like fiber channel or whatever network. Now it seems more and more vendors are disconnecting the BMC network because they can't trust the BMC, and they're only updating things attached to the BMC through the host OS because they can control the host OS.
Oh, interesting.
A number of big vendors are doing that, which I guess massively simplifies their networking in the data center. But it also, I think the primary reason was they didn't trust the BMC.
But I don't trust the OS these days.
Right. Yeah. It just, to Scott's point, it just shifts the attack surface is what it does.
One of the scary things I've heard recently is that a lot of the root of trusts are going to be moved onto the BMC, which scares me a lot.
Yeah, I wanted to talk about secure boot. Because around the time I had discovered fwupd is when I started to understand, not fully, of course, but I started to understand how secure boot works. And like my first project actually at Eclipsium was, how do I update my DBX on Linux? And then my next question was, okay, let's put how aside for a moment. Whose responsibility is it to keep the DBX updated when you're running Linux? Is it the OEM? Is it the BIOS or UEFI software provider? Is it the operating system, or is it some other third-party service? I think the answer still today is it's kind of up for grabs when we talk about Linux, perhaps.
Yes and no. So I agree with you in principle, but in practicality, no. And let me explain. So if you put the DBX in the firmware itself, that means that the OEM is responsible for updating the DBX, which means it comes from a centralized, trusted place. It goes onto every machine, and every machine is treated equally, right? Where that breaks is imagine you're running like RHEL 6, something EOL, and you haven't applied any of the secure boot updates, and then you do a firmware update, and the RHEL 6 shim, which was added to the DBX, is now stopping your machine booting. So you've literally installed a firmware update, and you now have a red access violation that means the machine won't boot. So I think what we've suggested to vendors is don't ship the DBX in firmware updates, because if we ship it in fwupd and using LvFS instead, before we deploy the DBX to your system, we can check, is anything in your EFI system partition affected by this DBX? And so a good example is if you have like the Dell recovery tools, which haven't been updated because you've been running Windows rather than running Windows. if you deploy the DBX without checking, it means you can never do a recovery. And so if you do the DBX via the LvFS and fwupd, it means that you are sure that your machine's going to boot the next time you restart it.
Right. And it's really funny. I was explaining this to someone on the internet in a forum, and they just weren't getting it because they were in that situation where, I don't know if it was a USB thumb drive, bootable drives, have this problem typically, but they were trying to apply the DBX update, and they're like, it won't apply. And yep. I was like, that's because your bootloader is in the DBX. And they're like, what? And then I tried to explain to them again, and they were like, oh, I'll just wait for another LvFS update. I'm like, that doesn't matter until you update your bootloader, dude. And it's hard for people to I mean, the complexity of secure boot in that root of trust is very confusing to users, and I don't fault them for that at all. I mean, I feel bad for this person. I'm like let's do a Zoom call, dude, and I show you some diagrams, right? Like that's the only. It's hard for users to grasp that.
Secure boot is a hard concept because you have to explain to the user essentially everything from boot guard right up to user space.
Yep.
And people don't care. Like, people just want their system to be secure, but actually how it happens is not that interesting.
Right. But I like that you're building these checks and balances. So what was interesting was when I was, how do I update? Let's go back to how do I update my DBX on Linux? Well, I found some hack backdoor kind of way to do it. And I saw you have a post actually where you talk about doing it. And then lo and behold, after I made my post months later, you're like, this is in fwupd. And then I was like, no, now when I present that same material, I'm like, this is how you update on Linux. You should use fwupd, because I think you've done a pretty good job and fairly comprehensive job, right, of allowing Linux users to update their DBX today.
I think so. Like, it's one of the most deployed. I think it's been deployed like tens of millions of times. So it's one of the most successful updates. I think what's interesting here is most users, like looking at the stats that we get from like the downloads and stuff, is that 99% of people don't actually type in commands into the terminal. 99% of people actually just click a button. So when we put like fwupd support into GNOME software, it meant that we increased the number of people deploying updates by 2 orders of magnitude.
Wow.
Making it so that you have literally, it comes up in the same place that you find all your normal software updates, and it comes up as like a DBX update from Microsoft, one button, reboot, done.
It's awesome.
So Paul, I got to ask, just because it's been so on everybody's mind after Black Lotus, I found that on October 7th, and as just an ad before it was found in the wild, and I literally didn't believe what I was seeing when it talked about it's on, across all platforms. Of course, it had a lot of other crazy features that we've covered in past shows. So without going into too much about Black Lotus, what kind of things would LvFS help somebody do in terms of the way that Black Lotus worked with using the Linux, MOK shim aspect? Is there any mitigation story with LvFS in that context that you can think of?
It's tricky because I don't really want like LvFS and fwupd to become like a secure boot, like kind of manager. I don't want it to be like digging around in your PK and everything. On the flip side, it's probably the right layer. So the answer to your question is no, there's nothing right now. And adding to the whole Black Lotus thing, I was talking to Microsoft literally about it yesterday. And one of the things I've asked them for about, I don't know, maybe over a couple of years now, was more transparency on the whole DBX update. So like why keys were added, what keys were removed, because stuff's removed from the DBX all the time as well. Like there's a famous issue with HP where they've run out of NVRAM flash space. And so to actually like do the DBX is really hard. And they have to remove things and ship it. It's horrible hacks they're doing. And so actually one of the things Microsoft has done is made the whole process a little bit more transparent so we can see what was added when and why. But they're still very tight-lipped on the whole Black Lotus thing and how they're going to fix it.
Did you notice the recent news from about a week ago where 2 of the bootloaders that our guys Jesse and Mickey discovered and did their talk at DEF CON about called One Bootloader to Load Them All? 2 of those they tried to do updates for, but they used the wrong hash values, the wrong type of hash in the entries, and so effectively those vulnerable bootloaders are still out there for anybody to use, and they're super scriptable, super powerful. Yes. Like, what attacker doesn't want to use that? And how can that be missed, just even from a QA perspective? How do they not even just at least
Microsoft two barrels about this week? So basically said, look, you said you patched this vulnerability. We had to take basically they used the file hashes rather than the authentication hashes.
Right.
And so we thought the vulnerability was fixed for about 9 months. And then now the hashes have been updated. And we're like, well, can we have some more visibility into this process so that we can actually verify and help as well?
Right.
Help write release notes, help tag CVEs and Vince tickets and things. Because it doesn't have to be this kind of sort of secret cabal that decides what goes in and what doesn't go in.
Yeah.
Yeah, it's interesting. I'm curious why a lot of that is shrouded in mystery from Microsoft, right?
So I don't think Microsoft wants to be in the certificate management business. I think it's essential. So essentially, there was an agreement a few years ago, again by Peter Jones, where Microsoft would sign the shim, which would allow Secure Boot to work with Linux. And since then, controlling the Secure Boot ecosystem has gone from being really important to Microsoft to, I think, a lot less important to Microsoft. And so it's increasingly hard to kind of get resources on that. One of the things we'd actually talked about was having like a Red Hat PK type, a Red Hat certificate thing, which vendors like Lenovo could ship as an alternate to the Windows one. But that gets political very quickly.
Yes, it's very true. It's very true. Tell me a little bit about your background with GNOME. Were you one of the developers on that project? So
I've been a GNOME developer for like 20-something years.
Okay.
I sort of started off writing, what was it first? GNOME Color Manager and Color D. Tell a lie. GNOME Power Managers first with HAL, and then UPower, then GNOME Color Manager, Color D, GNOME Package Kit with Package Kit, GNOME Software, which is now big, which is great. So I've been a GNOME developer for a long, long time, and I've learned a lot of my skills through GNOME. Like, actually learning how to code is superb. Like, the people there are like the top programmers.
That's interesting. That's my desktop manager of choice on my systems. But I think it's. I want to go back for a moment to when you introduced the feature to fwupd to be in the graphical portion. We saw that's what triggered this huge update for people's, and not just DBX, it's probably firmware as well. And it's interesting how that small little change, making it available in the GUI, like the functionality in the backend's the same, making it more accessible to users led to increased security.
When I added the feature to GNOME Software, I was the GNOME Software maintainer. So it's kind of like, it's sort of like I guess karma helping me out long term.
I gotcha. You're in the right place, right time.
Now we have like a GNOME firmware dedicated application, which just does firmware, but it's not like point, click, go. It actually allows you to downgrade and query and verify and do all the power user stuff as well. But yeah, so actually GNOME Software's, I guess, the first one and probably the best one. And like you say, kickstarted everything else.
Yeah.
So where do we go from here, right? So you have tons of insight and telemetry, and you've built this, and now we're looking at all this, kind of to up level this a little bit. Like, what advice would you give even to, like, quite frankly, like policymakers and folks like CISA to actually affect change at a national level or a global level, so that this problem is better mitigated going forward in the middle of chip wars and IT sanctions against countries like Russia in the middle of this conflict we have going on, and all these geopolitical kind of dynamics that are stressing the supply chain so heavily. If we're not careful, I just feel like we're going to end up in a worse situation going forward than a better one. So what needs to happen at like a policy level in your mind? If you could just be philosophical for a moment.
So I can be better than philosophical because I've talked to quite a few of the CISAs and the UK government, French government, etc. So one of the major things I want to one of the things I want to work on with US, French, UK legislation is providing updates for devices for longer. So if there's no point having a device that lasts 10 years, only having updates for 2.5 of those years. That makes no sense at all. So if you can't have legislation based on that, make for instance, the UK government says, okay, well, which laptops are supported? And there's actually graphs on the LvFS that you can look at and say, okay, for this XPS 13 has been supported for say 3 years, and it gets an update once a quarter. So they can use it for purchasing policy. Because these vendors don't do things because they're nice. They don't do things because they should. They only do things if you either stop them selling to someone they sold to before, or allow them to sell somewhere they've never sold to before, and then you can make them do stuff. And that's kind of like the carrot and the stick, so to speak. The stick is you can't sell to this person anymore. So a good example is ANSSI, the French government agency for security. They're now using the HSI tests before they buy hardware. So any laptop that doesn't enable secure boot by default fails the HSI tests and wouldn't be eligible for being purchased, which gives a massive onus on the laptop manufacturer to first of all test the security before they ship it to the consumer, and also to actually choose stuff that is able to be made secure. There's no point buying chips which can't have BootGuard enabled or something.
So this is fascinating to me, just because the U.S. government passed the executive order. And now there's a timeline in place for any vendor that wants to sell to the federal government to, at this stage, only attest to whether or not they're shipping secure code and have update policy. And that does, overtly include firmware. But that's only an attestation. So
I've worked with the first executive order with the is it NTIA, the Commerce Department in the US. Essentially, basically, because the first version of the executive order came out and said, right, we'd like SBOM for all critical software, and then a kind of a bracket saying like a low hushed voice, except firmware, which was sort of like a step in the right direction, but sucks. And I'm kind of pushing and hoping that executive order V2 will include firmware. So to that end, I've been talking to all the IBVs, like the AMIs, the Insides, etc., saying, look, here are the tools that we've developed. If you use these tools and you provide us the metadata, you get this little green tick, which means that you are now like Executive Order V2 compliant, essentially. And so if they do use the tools that we provided and give us the data, like macro came from Intel, CSME came from Intel, modem firmware came from QuickTel or whoever. If they do all of this, they get the green tick, then they're basically ready to go when all the SBOM regulations come in.
Love it.
Yeah, I think more and more we're seeing regulation driving some of the increased security standards for devices. I think it was the Josh Corman was on ESW last week talking about the FDA and the new requirement that they have to meet certain security standards in order to get FDA approval for a device that's used in a medical setting. And so also
water authorities, water sanitation checks that they do, the audits now overtly have firmware, and CJIS for criminal data has a ton, like over a dozen mentions of firmware overtly for vulnerability management and all sorts of stuff. So it's coming like one at a time, but I just want that, like you said, we want that top-down strategy to include firmware overtly, because ironically, the first executive order talked about the 5 aspects of what makes for critical software, because this is all about critical software. And if you look at all 5 criteria, like firmware is literally the quintessentially most critical thing, whether it's trust or impact or other dependencies that rely on it. Like it's literally the nexus of trust for the whole damn stack. So what are we doing if we're not including that as critical software by definition?
An example here as well. So like the little unifying receiver, which also has updates on the LvFS. The unifying receiver was affected by this vulnerability called Mousejack all those years ago. And yet that also is one of the most popular updates in the LvFS. Literally millions of those have been updated. And the consequence was, if you'd had a receiver plugged into your laptop sitting in a cafe, you could just take over someone's workstation and essentially own it without authentication. So that was hugely critically important. So I said, well, look, we need SBOMs even for like the peripheral devices. But then it gets really complicated really quickly, because you have like a mouse, right, made in the USA by a well-known peripheral vendor. Where's the firmware from? Okay, well, the main system firmware is from that OEM vendor. And then there's the radio, which comes from someone like Broadcom. And then there's another bit of firmware which does the interface between the two. So this one mouse has an SBOM with three entities in it, and the receiver has the same, sometimes different 3 entities. So just one peripheral device has an SBOM with 6 entities in. Now, I've talked to lots of vendors about SBOMs, and a lot of the worries they have is we don't know where the firmware came from, and that's the OEM telling you. So, like, who owns the? They know they have redistribution rights for this random QuickTel or Broadcom firmware, but they don't actually know who built it, where it was built, like how it was built, and that's frightening.
Yeah, that should be a mandate. I mean, because we're doing that on the software side, and we should be doing that on the hardware and firmware side too. Because you're right. If I'm making a mouse today, I may have a chip in there that, you know, I license and it's part of the manufacturing process, but someone upstream somewhere has developed the firmware and acquired, and that could go through 2 or 3 different vendors just to get to it.
So actually, it goes back to the carrot and stick thing. So the stick is that to do some things on the LvFS, if you don't include, for instance, an end-to-end test, you get to click lots of clicky buttons saying wave, 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 wave. So you make it difficult for the vendors to do the wrong thing. The other thing you can do is do the carrot. So, for instance, if you have like a unifying firmware with an SBOM in it, you get a little green tick on the LvFS product page, or you could have a red cross. Now, if there's anything a marketing department likes less, is a red cross next to their product.
Right. It's very
lovely, brilliant.
Richard, what other?
I don't know if it's being a psychopath or what, but like just basically getting companies to do things the right way using any method.
Richard, what other things in the future of LvFS and or fwupd have you excited?
So Google is pushing fwupd hard. So it's a requirement for the Works with Chromebook certification, which means that basically all the vendors that want the little sticker have to go through fwupd, which means that weirdly, so Chrome didn't necessarily want it from a security point of view. They were like a good chunk of their root FS was firmware updaters. So when I said, look, we can provide an NVMe firmware updater in like 6 kilobytes of code, they were like, wow, this is brilliant. And it meant they can audit the code. They don't have to trust the vendors. We don't have like 25 statically linked versions of glibc on each root file system. So they're pushing it really hard. So they've tested it with like, I don't know, maybe 50 vendors. And it's gone really well. And now they want to ramp up everything in like an order of magnitude, which is great because they can say to their entire supply chain, you have to use fwupd. Now, the conditions here is, because I'm a Red Hat employee, there can't be anything that's Chrome OS specific. So anything that Chrome OS, Linux gets for free, essentially. So this is why the partnership works so well.
That's awesome.
Yeah. I kind of like in a short term, I kind of think with this year we will get to 100 million downloads, like recorded downloads. I don't know how many actually people deployed. It's probably an order of magnitude more than that. But that's certainly something to celebrate and something I'm very proud of.
And how is the process of onboarding new manufacturers and firmware providers to LvFS going? I know there's some on there that I really want to see. You can see in my frame, there's a framework laptop, right? I want to see
on the LvFS. So the tricky bit is, so lots of vendors have an account, but are waiting for like regulatory or legal or even like senior management approval. So I'd say there's probably only 2 or 3 OEMs globally that don't have some experience using LvFS, which is awesome. The frustration is like I don't know, trying to give you a good example without dropping people in it, but like a lot of the server vendors, for instance, server vendors have been testing this stuff for a long, long time, and now they just have to get approval to release their precious firmware code to some random open source site.
I gotcha. Well, that's good.
I was going to ask that too about SBOM in general. Do you see resistance from vendors, especially towards the top of the supply chain, that are worried about like intellectual property, like aspects of this, and kind of not trade secrets, but that's not the right term. But exposing what your thing is built of is a competitive concern. We hear a lot. Do you see that as from your side as well?
So there's 2 elements to this. So one is, for instance, Lenovo might use an ODM. So Lenovo might produce a laptop model, but never actually touch it themselves. The ODM produces the device, builds the firmware for the device, is responsible for updating the device. It gets branded with Lenovo, but Lenovo never actually touched it at any point. So when you write the SBOM, one of the conditions the ODM has with the OEM is the ODM can never be referred to as the manufacturer. But so do you break the business agreement between the ODM, Lenovo, and the IBV ODM, or do you tell the truth in the SBOM? So you have a choice between, you have like a business confidentiality issue, or you have an SBOM is basically a lie issue. Now we haven't really fixed. So I have this thing called USWID, which is a utility for creating firmware SBOMs. And the way we've done it right now is said to the ODM, tell the truth. And then when we ship the firmware, we can patch it so that it actually says the OEM, which isn't something I'm terribly happy with, but it's one of those
middle ground
business relationships versus technical purity. The other issue is sometimes branding. So like when you buy I keep dunking on Lenovo, but if you buy a Dell laptop, it's a made in America laptop. And then you look at the firmware, and the firmware was built in, say, Taiwan, and the modem firmware was built in China, and the radio firmware for the Bluetooth chip was built in Singapore. And the branding of this all-American system is just not there. So actually finding out who built what where is sometimes eye-opening.
Yeah, for sure.
It's also eye-opening when you look at the SBOM and you find out that actually random companies just email random EFI binaries to lots of different OEMs. So exactly the same checksum EFI binary can be found in a Lenovo firmware and a Dell firmware because it's been sent to them by the network card vendor. Frightening.
Well, Richard, I want to thank you so much for appearing on the show today. The links to the projects, LvFS and fwupd, are in the show notes. Richard, thank you again for appearing on Below the Surface. We'll see everyone next time. Thanks for tuning in.